Good day everyone, here's our math challenge for today. And here's our question. Given these three congruent circles with the radius 1 unit, the question is, what is the area of the blue shaded region? Now, if you want to try this problem, just pause this video. We have 20 seconds and timer starts now. Time's up. Now, let's answer this question together. Our goal here is to solve for the area of the blue shaded region. First thing to do is to locate the centers of these two remaining circles. And next thing to do is to connect them, of course. And then, from the centers of these two bottom circles, let's draw a radius directly to the point of tangency, like this. And since all of these circles are congruent, it follows that all of its radius must be equal to 1. And now, take a look at this figure. To find the area of the shape, what we're going to do is to get the area of this equilateral triangle and then subtract 3 times the area of this sector. Thus, the area of this region must be equal to s squared times square root of 3 over 4. This is the area of an equilateral triangle given its side, minus 3 times the area of this sector, which is equivalent to minus 3 times the area of a sector, which is equal to theta over 360 times pi r squared. Now the question is, do we know the length of the side of the equilateral triangle? And the answer is yes, because the length of this equilateral triangle must be 2. Now how about the length of the radius of the circle? And we know also that it is equal to 1. And the question is, what is the angle theta that we need to find the area of the sector? Now take note that this triangle is an equilateral triangle. Therefore, its angle measures exactly 60 degrees. Therefore, this theta must be 60 degrees or 60. Now, let's substitute. S must be equal to 2 because the length of the side of this triangle must be equal to 2 units. And then the length of the radius must be 1. And then the theta is 60 degrees or simply 60. Now let's simplify. 2 squared will give us 4. And then 4 divided by 4 will give us 1. Thus, this is equivalent to square root of 3. Now, 60 over 360 is just 1 over 6. 1 squared is just 1. And then 3 times 1 over 6 will give us 1 half. So we have square root of 3 minus 1 half times pi. And 1 half times pi is just pi over 2. Therefore, the area of this region must be equal to square root of 3 minus pi over 2 square units. Now, how about this bottom part? So how do we get the area of this bottom part? So what we're going to do is to take the area of this rectangle minus 2 times the area of this quarter circle. Thus, the area of this region must be equal to length times width, the area of the rectangle, minus 2 times the area of a quarter circle, which is equivalent to 1/4 times pi r squared. Now, let's simplify this a little bit, because 2 times 1/4 will give us 1 half. Now, the question is, do we know the length of the rectangle? And yes, because the length of the rectangle must be equal to 2. How about the width? The width is just 1. How about the radius of the circle? This is just also 1 unit. Now let's simplify. 2 times 1 will give us 2. 1 squared is just 1. And then 1 half times pi will give us pi over 2. So this is the area of this shaded region. Therefore, the total area of this two shaded region must be equal to square root of 3 minus pi over 2 plus 2 minus pi over 2. Now, let's combine similar terms. Negative pi over 2 combined with negative pi over 2 will give us pi. Therefore, the area of the blue shaded region must be equal to square root of 3 plus 2 minus pi. And don't forget the unit, we have square units. And as always, we are done.